Today we're going to talk about section 6.3 inverse trigonometric functions first, and in the second part we will talk about verifying trigonometric identities. Okay, so let's start. As we all know at this point, sine of 30 degrees is just equal to 1/2, right? 1/2. Now I know it because I have memorized these basic results, right? But in case you need to confirm this, for some reason you're not sure, you can always look at our worksheet, the unit circle worksheet. That one is going to give us all the trigonometric functions for our main angles, right? So welcome, Gabriela. We just started. We are saying that in order to get sine of 30 degrees, for example, you just look at this unit circle worksheet. Is there second coordinate here 1/2, right? For 30 degrees, sine of 30 degrees 1/2. Very good. Yeah, in case guys you don't know where to get this sheet with formulas, important sheet with formulas, here is the link, the direct link. Okay, let me give you the direct link. There you go. Or look at in Blackboard or in our website, it's there, right? The unit circle sheet and their useful sheets. Okay, great. So sine of 30 degrees 1/2, right? 1/2. Now the question is there a way to say this statement in reverse? In reverse. And the answer to this question is yes, there is a way. There is a way to say this in reverse. Mathematicians figure it out. Instead of saying this, you can say equivalently that the angle whose sine is 1/2 is 30 degrees, right? 30 degrees. Great. So now, mathematicians express this formally by saying that the arc whose sine is 1/2 is equal to 30 degrees. Okay. Now, why they use this word arc? Arc. Well, they use it because arc means angle. Arc means angle. Remember, I gave you guys this explanation when we went over the unit circle, right? When you work in the unit circle, there is a way to put in one-to-one correspondence the angles in radians with the arcs, right? With the arcs. So this is the arc. The arc and the angle, when the radius of the circle is 1, are in one-to-one correspondence because of this formula, right? Let's say this arc is represented by the letter S, S equal R times theta. But if R is 1, notice S equal theta. So one-to-one correspondence between the arc and the angle. So mathematicians use this word arc to refer to the angle, right? The angle whose sine is 1/2 is equal to 30 degrees, okay? Now, equivalently, you can say this, the arc or the angle, right, whose sine is 1/2 is equal to 30 degrees, but converting this to radians, remember 30 degrees is pi over 6, right? In radians, And this is actually what we're going to use a lot because the output of this arc sine function that we're going to define next formally should be written in radians, right? Very rarely you will see this. Most of the time you will write the angle here in radians. 30 degrees, pi over 6, right? How do I know? I converted, right? Remember there is a way to convert, or you can always look at this important unit circle sheet, 30 degrees, pi over 6. You see it? It's there, it's there. All right. Now, guys, let's try to define this arcsine operator formally, right, as a function. So for that, let me show you the graph of the sine function. Okay, first, the graph of the sine function, remember, it starts at 0, reaches its maximum 1, back to 0, minimum -1, back to 0, right? That's over a period. But remember, we explained that if you continue to the right, to the left, what happens over a period repeats itself to the right and to the left, right? So therefore, the graph of the sine function as a whole or entirely should look like this, more or less, right? More or less. A curve that looks like this. Like a wave, right? And we saw it in the previous lecture, right? More or less like this, right? Now I have a question for you guys here. As a whole, this infinitely long sine function, right? Is it a one-to-one function? What do you think? Yes or no? And as a hint, I can tell you, in order to see if a function is one-to-one, there is this so-called the horizontal line test, right? If it passes the horizontal line test, yeah. Yeah, but remember the trick is here, right? That I'm not considering just this part, Mujina, right? Now I'm considering the whole thing, Does the whole graph pass, will the whole graph pass the horizontal line test? Let's look at this carefully, right? Yeah, remember the horizontal line test says, yes, question is that? Oh, no, exactly, right? Excellent, Mujina. No, it's not one-to-one, right? Because if we draw horizontal lines, notice, look, 2 points, right? 2 points, right? 2 points of intersection, 2 points of intersection. It's not one-to-one, right? As a whole. Now, but part of it, right? Yeah, part of it. Yeah, vertical line test is to verify if the graph represents a function, right? But horizontal line test is to verify if the function is one-to-one. Yeah, very good. Good question there. Great. So this one, no, right? No, it's not one-to-one function. However, if we carefully choose part of this function, we can take a piece that is one-to-one. What do you mean, Professor? A piece of this one-to-one? Well, I could take, for example, this piece, right? From here up to here. And this red piece, right? This red piece, you can see that the red piece, part of the sine function, is one-to-one, right? Look, just 1 point of intersection here, 1 point of intersection, right? So mathematicians decided to take this piece, this interval, the one from -pi/2 to pi/2, in order to be able to invert this sine function, right? Because as a whole, we saw that it's not one-to-one, right? F of x equals sine of x has an inverse function on, look, -pi/2, comma, pi/2, right? Over this interval, the sine function is one-to-one, right? Over this interval. Let's mark it here. Very good. So then over this interval, we can define formally our inverse function, right? We can say that the inverse sine function is defined as y equal arc sine of x, if and only if x is equal to sine of y, right? It's just this statement in reverse, right? In reverse. Okay, but we gotta make sure that when we say that, our x is between -1 and 1, right? And our y is between -pi/2 minus 90 degrees and pi/2 90 degrees, right? 90 degrees. Hello, guys? Yeah. So in order to invert this function, we have to consider just this piece, right? Outside this interval, doesn't make sense to talk about sine inverse, right? Between these two values. Very good, very good. So now note arc sine of x is the same as sine inverse. Mathematicians decided to shorten this representation by writing sine with this -1 on the top of x here, sine inverse of x, okay? Here, do not confuse this with exponents. I'm gonna first let you know how you read this. This is read as sine inverse of x first, of x. Do not confuse this, the -1, right, with the exponent. It's not exponent, it just means sine inverse, okay? Do not confuse -1 with exponent. It's just sine inverse, okay? All right, great. Now some examples here. Find the exact value of each expression. Sine inverse of a square root of 3/2. Okay, I have to think of an angle having sine equal to square root of 3/2, right? Let me write here, sine of some angle will be a square root of 3/2. What is that angle? Well, since I have memorized some basic results, I know that sine of 60 degrees is a square root of 3/2, okay? But now, in case you have not memorized this, or in case you are not sure what angle has sine square root of 3/3, don't worry. From unit circle sheet, if you pull it out, I gave you the link, right? You look for a square root of 3/3 here in the first quadrant. You can see it here, right? You look for the second coordinate, because first coordinate gives you cosine, remember? Second coordinate gives you sine. So this angle here, 60 degrees, has a second coordinate square root of 3/2. So therefore, the sine of 60 degrees is square root of 3/2, right? Great. Very good. So that's how you find it. Pi/3, right? Pi/3. You saw it next to 60 degrees. Pi/3. So I'm gonna use that because remember, we said that mathematicians prefer to write the output of this sine inverse function in radians. Pi/3, right? Pi/3. Okay, so you write it here, pi/3. You're done. It's some backward thinking, right? Yeah. Instead of looking for the result of sine of pi/3, you look for the angle given the result, right? Great. Now, here is another one. What should be sine inverse of negative square root of 2/2? Well, let's write it here. Sine of some angle should be negative square root of 2/2, right? So I gotta look for angles between negative pi/2 and pi/2, such that the sine of the angle is this guy, right? Between these values, the angle. So I'm gonna go back to the unit circle, right? Sheet. And again, I have to look for angles here between 0 and pi/2, but also here, right? Between 0 and negative pi/2, right? Here or here. Now, if I look here on the first quadrant, I see that sine of 45 degrees is the square root of 2 over 2, right? So now, notice, therefore, if you go in this direction, minus pi over 4 or minus 45 degrees should have sine negative square root of 2 over 2, right? Very good, very good. Very good, Mujina. Yeah, but here is the trick. 315 is the angle, right? It's showing the sine this, right? But remember the restriction. Remember we we said that the angles that we take, that 315, the one that you mentioned, should be over here, right? It's outside of the interval where I have to choose my angles. It has to be between 0 and pi over 2 or between 0 and minus pi over 2, right? Here or here. So in other words, the search has to be done on the first quadrant, 0 to pi over 2, or on the fourth quadrant, 0 to minus pi over 2, but you have to use this. This is the angle that you mentioned, right? 315, but go in clockwise direction. If you go clockwise direction, this is negative 45 degrees, right? You follow? 45 degrees here, counterclockwise, clockwise, minus 45 degrees, right? Minus 45 degrees. That's what we have it right. Okay, it's tricky because it's backwards and there is a place. Yeah, I'm glad you understood. Yeah, it's tricky and you have to look or do the search here. Very good. Minus pi over 4. Minus pi over 4. That was the angle, right? So since, yeah, we should read it here. Since sine of minus pi over 4 is negative square root of 2 over 2, then sine inverse of negative square root of 2 over 2 is minus pi over 4, right? Very good, very good. Excellent. All right, moving on. Let's see more examples. Use the calculator to find the value of each expression. Round. Yeah, we will do this later with the calculator, but for now, let's just do it using the unit circle, right? This one also gotten from unit circle sheet. Yeah, great. Okay, so before we move on, I'm gonna ask you to do some exercises here. Can you try using your unit circle to figure this out? Let's start with number 2. Can you try this? Use the unit circle sheet. I'm gonna put it out here. Yeah, very good. What should be the angle whose cosine is a square root of 2 over 2? Yeah, the choices are there, so maybe the unit circle should be here. Smaller. Yeah, you have the choices there. You have the unit circle here. Yeah, what should be the angle whose cosine is the square root of 2 over 2? But that, this is cosine. We haven't done cosine. It has to be sine. Sorry. Yeah, but very good. Anyway, yeah, very good. But let's do this in order, preferably because we have to keep an order. This one is the one that we should do. Really, this one. Because we are dealing with sine. I will explain cosine next. Yeah, this one is better. Yeah, can you try this? Can you try this, guys? Very good. Yeah. Was the answer for the previous was correct? Ujina, very good. So let's try this now. Again, look at the unit circle, right? Look for an angle whose sine is 0.5 is 1/2, right? 1/2, so 1/2. What should be that angle? So this one, 1/2. Very good. Great, excellent. Ujina, excellent. Pi over 6, right? Yeah. I know it by heart, right? Sine of 30 degrees, 1/2, sine of pi over 6. Pi over 6 is the same as 30 degrees. But in case you don't you're not sure, look at the unit circle sheet. 30 degrees, pi over 6 in radians has as its sine 1/2, right? Second coordinate 1/2. So this there. Very good. Excellent. So this should be definitely the C. Very good. All right. Now let's go ahead with cosine functions so we can do more, and then tangent. The cosine inverse, tangent inverse, right? Yeah, very good, very good. But before that, also, I want you to be able to get this using the calculator, okay? So I'm gonna give you some examples and we will go back to this. So using the calculator now, how do you find sine inverse? In case the angle is not special, the quantity given is not special, in general, right? How do you compute arc sine or sine inverse? Let me explain to you. Arc sine of 0.4. How you do it? Well, you go to a calculator, right? And you are going to look for the function arc sine or sine inverse. They are the same, right? They are the same. So we go to functions and you look for sine inverse, okay? Sine inverse, and then you type 0.4. By default, our Desmos scientific calculator will output the answer in degrees, as you can see, right? But that's not the one that we want. We want the answer in radians, because the output values for this trigonometric, for this inverse trigonometric function should be in radians. So this is the one that you have to take, okay? 0.411. Follow the instructions for rounding. They say round the answer to 2 decimal places. So we write 0.41, right? 0.41, 0.41. 0.41. Very good. Now, sine inverse of 0.65. Again, you go to the calculator, to the Desmos scientific calculator or any calculator of your choice. You're going to look for the function sine inverse. Welcome, welcome, Jay. We just started. Let's continue. We are showing how to compute sine inverse using the calculator at this time. Sine inverse of 0.65. Function. You go to sine inverse. Here, 0.65. Okay, close. By default, will give you the answer. It will give you the answer in degrees, but we don't want this in degrees, we want it in radians. So change it to radians, 0.707. They wanted you to round this to 2 decimal places. So this should be 0.71, right? 0.71. Very good. 0.71. Yeah. So it's simple. Okay. So use the calculator. Now practice here so we can move on. Practice on this one. Can you try this? What should be the sine inverse in radians, remember, of this guy? Can you try that? A hint, use your scientific calculator. Look for the function sine inverse. Remember, this should not be confused with exponent. It's sine inverse. It's not sine raised to -1. It's sine inverse. Inverse function of sine, right? Yeah. So use this function. Go ahead, guys, try. And let us know if you figure out the answer. Well, let me show you the choices here. I see some activity in the chat room. Let's see. Let's check it out. Very good, very good. Excellent, excellent. Rounded. Ujina, excellent, excellent. Very good, you got it. Excellent. So this guy, right? Very good. You know, when you do this, you just look for sine inverse in the calculator, this function, and then you type 0.7 equal, right? Make sure you are working in radians. I'm going to write here as a note. Make sure your calculator is set to work in radians, right? Work in radians. Very important this, guys. Otherwise, you're not gonna get it. Okay, radians. Very good. Excellent, excellent. Great, great, great. Yeah, very good. It's important to set it to work in radians because otherwise you're not gonna find it here or you're gonna pick the wrong one, right? The wrong one. Okay, just make sure radians. Great, excellent. All right, so now let's talk about cosine inverse, right? Cosine. We talk about sine inverse. Let's talk about cosine inverse now. Remember the function y equal cosine of x. We saw is this, right? It looks like curve V, right? When graph. So let's recall that. So it looks like this, right? Over a period, right? It reaches this point and then goes like this, ends up here, somewhere there, right? Yeah, look like this, right? Yeah. Now, if this is what happens over a period, right? Over a period. But if you continue, this is what happens over a period, right? Yeah, but if you continue to the right, to the left, then this goes here like this, right? Continues there. And similarly here, look, continues here, down here, something like this, right? Yeah, now, question for you guys. As a whole, is this function f of x equal cosine of x a one-to-one function? Is it one-to-one? What do you think? Type in the chat or let us know, yes or no? Let's see. Mojina, yeah, you made my day. No, right? No. As a whole, it's not one-to-one. Because remember, there is a test to verify if a function is one-to-one. Look, if I draw a horizontal line, that's going to meet this function more than once, right? So it's not one-to-one as a whole, right? If you take the whole cosine function. So mathematicians were aware of that, right? That this function as a whole is not one-to-one, but they asked themselves, right? Could we pick a part of the function, a piece of the function, so that it is one-to-one? And the answer was yes. Before I took the piece from negative pi over 2 to pi over 2 for sine, it worked, but it's not going to work here, right? Look, if you take this piece, it's not one-to-one, right? So mathematicians had to settle with this other piece. Look, from here, from 0, down here, right? Up to pi. Follow that, guy? Yeah, this red piece will pass the horizontal line test, right? Look, one point of intersection, no matter what horizontal line you draw, right? So this piece of the cosine function is one-to-one, right? So it can be inverted. So f of x equal cosine of x has an inverse function on the interval from 0 to pi, right? From 0 to pi here. Very good, guys. Yeah. Very good. And formally then, the inverse cosine function can be defined by saying this: y will be equal to arc cosine of x. Remember, arc means just angle whose cosine is x, if and only if x equal cosine of y, right? It's just set in reverse. Very important, where x has to be between -1 here, and 1, and y, the angle, right, has to be between 0 and pi. Okay, try to remember that, guys, right? Because this is where you have to look for the angles whose cosine is going to be some given number, okay? Between 0 and pi. You're talking about first quadrant and second quadrant now, right? Yeah. Be aware of that. Note, arc cosine is the same as cosine inverse. Mathematicians decided to replace this arc word with a -1 on top of cosine. This should be read as, let me show you how this should be read as, read as cosine inverse of x, cosine inverse of x, cosine inverse of x. Do not confuse this -1 with exponent, with -1 with exponent. It's not exponent, okay? With exponent. This is not 1 over cosine, right? It's not cosine raised to -1. Instead, this indicates cosine inverse, the inverse function of cosine, right? Yeah. Very good. Examples here. Find the exact form this. Okay, so let's do that. Find exact form this. Do it from scratch. Cosine inverse of a square root of 2 over 2. What should be that? Well, in order to answer this question, this is asking me, what is the angle whose cosine is a square root of 2 over 2, right? What is that angle? Well, I gotta figure out an angle whose cosine is a square root of 2 over 2. What is that? If you have memorized basic results, the one that comes to mind is 45 degrees or pi over 4, right? But if not, go to your unit circle sheet, just gave you. And in case you don't have it, guys, here on the chat, this is where it is, right? It's also on our website in Blackboard. Okay, so you look for an angle between 0 and pi. We are talking about first quadrant and second quadrant now, whose cosine is a square root of 2 over 2. Now, for cosine, remember, cosine is the first coordinate, right? So look for the first coordinate. Here, I got here a square root of 2 over 2. The angle is 45 degrees, right? It's on the first quadrant, so good, between 0 and pi, right? So therefore, I got an angle, 45 degrees, pi over 4, right? It's written also there, pi over 4. The cosine of pi over 4 is the square root of 2 over 2. Therefore, cosine inverse of a square root of 2 over 2 should be pi over 4, right? Pi over 4. It's just this statement in reverse. Here's another one. What should be the cosine inverse of negative square root of 3 over 2? Well, I have to find an angle whose cosine is this guy, negative square root of 3 over 2. It's a tricky one, so I'm going to go back to the unit circle and look for an angle whose first coordinate is this, right? Look through first quadrant, second quadrant. Here, I found one. This guy, right? Negative square root of 3 over 2 is the cosine of this angle. But what is that angle? Look here, 150 degrees. Since mathematicians want the angle in radians, take this, 5 pi over 6, right? 5 pi over 6. So cosine of 5 pi over 6, right? 5 pi over 6 is negative square root of 3 over 2. So cosine inverse of negative square root of 3 over 2 should be 5 pi over 6, right? Follow, guys? It's in exact form. Yeah, and I want you to practice and then I will show you this part, okay? Let's practice here quickly. Can you figure out this? Cosine inverse now, cosine inverse. Cosine inverse. Yeah, this one. Figure this out. Do. What should be that in exact form? If you want help with the unit circle, here it is. Yeah, what should be the answer for this? Jay, good, but the thing is that is cosine now, right? Remember cosine. You gotta look for the first coordinate. First coordinate should be equal to a square root of 2 over 2. It's close what you said, but it's just that I think the one that you gave me would give me a negative value. It has to be positive, right? Yeah, positive. Yeah. Aha, Jay. Now, very good, very good. Yeah, now it's fixed. Great, right? Look for an angle that is either on the first quadrant or on the second quadrant. Remember, the angle has to be between 0 and pi. Whose cosine is this? Well, look for first coordinates, right? Aha, I found one angle here whose first coordinate is square root of 2 over 2. That's pi over 4, right? Or equivalent to 45 degrees. We choose pi over 4, the representation in radians, so it should be this, right? Very good, very good. Yeah, this guy equal pi over 4 using the unit circle. Great. Now, try to do this. Let's try to do this using the calculator. But for that, let me show you this first quickly so we can move on to tangent inverse, okay? And then we're going to do some compositions with these inverse trigonometric functions. Sometimes they might ask you to compute cosine inverse of an angle that is, not as an angle, of a real number that is not special, that cannot be found on the unit circle. For example, this, compute r cosine of negative 0.63. Round your answer into 2 decimal places. Well, what do? Well, simply we take our decimal scientific calculator or any scientific calculator of choice is saying r cosine, but we know that r cosine is the same as cosine inverse, right? Cosine inverse. And then we type the real number, negative 0.63. Then by default, my decimal scientific calculator gives me the answer in degrees, but mathematicians, remember, want this answer in radians. So switch it to radians, the answer should be 2.252. This rounded to 2 decimal places is just 2.25, right? 2.25, very good, 2.25. So 2.25, very good, guys, very good. Rounded, right, to 2 decimal places. Based on this, can you try now on your own this exercise here? Cosine inverse of 0.8. Try to do it using your calculator, using your decimal scientific calculator or any calculator of your choice, okay? Go ahead, guys. Cosine inverse. Aha, I see some students quickly. Got this done, very good, very good. Cosine inverse of 0.8, right? Very good, very good. Jay, excellent, excellent. Very good, very good. Very good. Aha, excellent. Yeah, so we just use our calculator, right? And we look for the function cosine inverse, right? Cosine inverse is here. Then we type 0.8, right? The real number. And then the answer comes up in degrees by default. I gotta switch it to radians. Switch it to radians, 0.643, rounded to 2 decimal places, 0.64, right? 0.64. So they should be 0.64. That's it. Excellent, excellent. All right, guys. So now I think we should go over tangent inverse, okay? Tangent inverse, then we will do some composition, some combinations of these inverse trigonometric functions. Aha, for tangent now. Let's recall what is the graph of the function y equal tangent of x first, okay? Let's recall that. Remember, I showed you in a previous lecture that if you graph y equal tangent of x, you're gonna get something like this, right? These elongated chairs where you cannot even sit down, right? It's very, very elongated chair. Look like this, right? But it's not just this, right? This elongated chair. It's an infinitely infinitely many elongated chairs that come along, you know, to the right, to the left, right? Like this. And the question again, guys, this function as a whole continues here, right? Dot, 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 dot. This function as a whole, is it one-to-one? Anybody could answer that question? The function as a whole, one-to-one? I see. Very good, Jay. No, right? Yeah, one piece of it, one chair would be one-to-one, right? But not the set of all the chairs together, because if you draw the horizontal lines, notice, if you take all the chairs, look, 1, 2, 3 points of intersection, right? It's not one-to-one, right? Doesn't pass, it will not pass the horizontal line test, right? As a whole, the function. But if I cleverly choose one piece, for instance, just this chair, right, the one in the middle, this will pass the horizontal line test, right? Follow, guys? Yeah, so even though it's not here, mathematicians realize that if you take just this piece, for instance, right? Again, we're going back to minus pi over 2 here to pi over 2, right? Where the vertical asymptotes are for the tangent function. So if you take this piece, just this piece, this piece will be one-to-one, right? It will pass the horizontal line test. So mathematicians then decided to do the inversion of this tangent function over the interval minus pi over 2, comma pi over 2, right? F of x equal tangent of x has an inverse function on the interval minus pi over 2, comma pi over 2. Important remark. Notice that now I'm not using brackets here, right? Professor, why you don't use brackets? Well, because we are not touching negative pi over 2, right? It's just that the graph gets closer and closer to it, right? Here also, look, very close to pi over 2, but never pi over 2. So you have to use parentheses. So again, the search for an angle given a real number has to be done again between first quadrant from 0 to pi over 2 or fourth quadrant, right, from 0 to minus pi over 2, right? Just like we did for the sine function, right? Very good, very good. Okay, guys, so the inverse tangent function is defined formally as this: y equal arc's tangent of x. Arc means angle, right? Angle whose tangent is x. If and only if x equal tangent of y, right? Is this in reverse, right? Where your angle must be, you know, chosen between negative pi over 2 and pi over 2. We explain why, right? Because it is over this interval where the function is one-to-one. All right, so be careful when you pick the angle, right? It has to be between these two values. Note arctangent is the same as tangent inverse. Tangent inverse, right? Yes, so instead of arctangent, you may find tangent inverse in your homework on the exams. They are the same, they are the same. And let me write here how you should read this, right? How you should read this tangent inverse. This read as tangent inverse of x. Do not confuse, again, do not confuse this -1 with exponent, right? This -1 with exponent. It's not an exponent, right? We're saying it just says tangent inverse, right? Tangent inverse. It's just notation. All right. Examples: evaluate in exam form tangent inverse of -1. For example, suppose they ask you to find the tangent inverse of -1. Well, in the back of your mind, you have to think of an angle whose tangent is -1, right? What should be that angle? Well, I know that tangent of this angle, 45 degrees, right, is 1, right? 1. That's something I know by heart. If you want to get it from the unit circle, you can think of this way. Look for an angle whose sine and cosine, they look exactly the same in value. Remember, tangent is sine over cosine. So if you divide sine over cosine, if these two values are the same, that should be 1, right? That's how I get tangent of 45, 1. Okay, great. Help yourself out with the unit circle. But now this is negative. From here, I can say that then tangent of negative 45 degrees is equal to -1. Now, negative 45 degrees is negative pi over 4, right? 45 degrees is pi over 4 radians. I see a comment in the chat. Yeah, Mohina, now, yeah, now we're talking. Very good, excellent. Minus 45 degrees, right? Yeah, that is what goes here, right? The tangent of minus 45 degrees, but 45 degrees is pi over 4, right, in radians. The tangent of minus pi over 4 is -1. Using the backward thinking, then that tangent inverse, the angle whose tangent is -1, has to be pi over 4 negative, right? Very good, very good. Great. This is in exact form. All right. Now, sometimes they will ask you to do this not in exact form, but in approximated form. You do it with a calculator in a similar way we did it with cosine and tangent, and cosine and sine, right? Yeah, let's practice and then we'll show you this part so we can go over compositions. Okay, so let's practice now. Worksheet here. Can you try this one? I'm gonna give you a tricky one. Yeah, I'm gonna do it for you, okay? So it's very tricky. How can you figure out tangent inverse of square root of 3 over 3? Well, we have to think in the back of our minds an angle whose tangent is square root of 3 over 3, right? I gave you a table with results. From there, you can get it, this angle, but if not, look at the unit circle. In the unit circle, remember tangent is sine over cosine, right? Sine over cosine. So I gotta look for some angle whose sine looks like this, cosine look more or less like this, and the division will give me this, right? And the search has to be done in the first quadrant from 0 to pi over 2, or in the fourth quadrant, negative angles from 0 to minus pi over 2. Look here, I found an angle that more or less is giving me the tangent would be sine over cosine, right? Could be this guy. How do I know? Well, let me show you here. Look, if you take here this guy, 30 degrees or pi over 6, notice tangent of pi over 6 will be what the quotient of this guy, 1/2, and a square root of 3 over 2, right? 2 cancels with 2, right? And I end up with 1 over a square root of 3. Rationalizing meaning multiplying by square root of 3 here, by square root of 3 here. This is square root of 3 over a square root of 9, which is 3, right? So I got an angle whose tangent is square root of 3 over 3. That angle is pi over 6. So that's the angle that goes here, right? You follow, guys? It's a little bit tricky, or you can get it from the table. I gave you a table, remember, with all the results for the angles 30 degrees, 60 degrees. And you will see that this guy is just 30 degrees, okay? All right, very good. So use your unit circle to help yourself out. Let's erase this part. And let's continue. All right, so now this therefore pi over 6, right? So pi over 6. So pi over 6 here. Then the answer should be then tangent inverse of square root of 3 over 3 equal pi over 6. Very good. This guy. All right, now can you try some stuff with a calculator and then we will move to composition. Okay, cosine inverse. I look for tangent inverse. Yeah, great, excellent. Can you try this, guys? Try number 8. Can you try this? Using the calculator. Using scientific calculator. And round it to 2 decimal places, right? Can you do that? Very good. Tangent inverse of 1.6. Very good, Jake. Very good. Yeah, excellent, excellent, right? You just look for the function tangent inverse, right? It's here, tangent inverse of 1.6. And that's gonna give you the answer in degrees by default. You switch it to radians, 1.01, right? 1.01 rounded to 2 decimal places. So the answer is just A. Excellent. Okay, great. This is this. Can you try now? Quickly, 9, you have to do it in your homework a lot. Do number 9 now. Sine inverse of 1 over 8. Can you give us the answer for that quickly? We can take the break. Yeah, very good, very good. Yeah, make sure you guys know how to use your calculator to compute this. Mujina now, very good, excellent, Mujina. Excellent, excellent, right? You just go like this. Sine inverse of 1 over 8. And that is 7.18 in degrees, but you switch it to radians, 0.12. Rounded to 2 decimal places, 0.13, right? Excellent, excellent. Yeah, so this guy, right? Can you try this? In the homework, you will encounter this type of thing with radicals. So try it now. Do this one. And we'll move on to composition of these inverse functions. Combining, right? Inverse trigonometric function. Yeah, try to do cosine inverse of negative square root of 6 over 3. Type it out in the calculator, right? Number 10. Yeah, it's a little bit tricky to type it, I think. Number 10. Jay, excellent, excellent. Yeah, you made my day. Very good, very good. Simply go to functions, find cosine inverse, and then within parentheses type minus square root of 6 over 3. It will come out in degrees by default, but switch it to radians, 2.526 rounded to 2 decimal places, 2.53, right? 2.53. Excellent, excellent.